Hey everybody, and welcome back if you've been here before. Uh, this video is the second installment in my Brown Sharpe No. 2 surface grinder rehab. If you like to watch videos of cleaning machines at 10 times fast forward, or if you want to learn about latching relays, electronics, and motor starters, then you're at the right place. This video is full of that stuff. Just a little other housekeeping note. There are a number of wiring diagrams and schematics that are part of this video, and download link to those can be found in the description below. So without any further ado, let's get going. I want you all to remember that I'm just another yokel who's not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts. I'm out here again today, and we're going to begin degreasing this guy with degreaser, rags, and some elbow grease. Thought about using the pressure washer, but I just don't feel comfortable with that. Yeah, it doesn't seem like a good idea. So I'm just not going to even get water anywhere near it. As with anything, we're going to start at the bottom. Just like your car, you don't want to have all the dirt from the top come down over everything else. So we'll just start working near the bottom. All right, I'm bringing in the heavy guns. This is actually Zep Orange diluted 50-50 with water. This is something called Citrusolve, which I think is a little bit more environmentally friendly. I think it's more diluted. I don't remember now. It's been on my shelf and I use it. We're going to take a break from cleaning and just take this switch off. This switch is actually does not do anything. Well, as far as I know, it doesn't do anything. The main switch is on the front, and this switch works. This is an on-off switch, but I don't believe that this thing does anything anymore. It certainly is not shown in the manual. So maybe the switch on the front at one point failed, and they put this on here and then didn't use it anymore. I don't know. Your guess is as good as mine. This is cool. Look at this thing, man. This is clean inside. That's what these switches are all about. These heavy duty, I don't know, environmentally protecting. These are the heavy duty switches where you hit it with a bomb and it's still okay. I see wires going somewhere, so I guess it's hooked up to something. And I was just thinking I would take it apart because if it's not being used anymore, I would go ahead and it'd be easier to clean, and then I might just close this up. But I am surprised that it's still hooked up. You know, looking at this more closely, actually, I'm wondering if this is a door. I don't see. I can't. There's a casting on the back side of this, which I cannot. So I can't get to the back side of this thing. But there are two screws over here, one at the top and one at the bottom. And I'm not. Look at I'm betting that there's a hinge under here. Well, would you look at that? It seems like there's a trick to opening it, though. I almost feel like there's a secret lever or something. What is this here? Turns out that I actually missed a screw here. And I think this might be important. Yeah, look at that. That just fell off. Does that get us any closer, though? I really feel like this has something to do with it. Like when it's turned off, it can open up. I have an electrical cabinet like that where it will only open when the switch is in the off. There we go. And yep, that was the case. Look at that. I should have learned my lesson. Huh. Okay. Okay. Huh. I still don't understand quite how that works, but that's okay. Look at that. Here we go. We got a starter here. Looks like a pretty old one. Oh my gosh, yeah, this is all Allen Bradley stuff. Well, this thing here is definitely the starter. And this is what? Some kind of a transformer, maybe for controls, but there are no controls on this thing. Right, I poked around in here, and I think this is going to fall under the heading of I'm going to come back to this later and focus on cleaning for now. Good news is everything works. I see where the wiring for this outside switch is going, but it never seemed to be matter whether it was on the on or off position. I was turning it on and off using the button on the front cover. So, for now, I took some pictures of this stuff. I'm going to do some research, and I'll come back when I know more. Well, once again, it's the next day, and due to some memory issues and probably my exuberance, I somehow deleted my clip from yesterday. I only made one, and it was about derusting the table on the surface grinder. So it's been sitting overnight. I'll show you what I did. I'm not sure whether this is a successful way to do this, but I took some pig mat paper towels and just covered the surface of the table and then poured Evaporust on it and just let it sit overnight. I had these cloths on top just to prevent evaporation, and I'm not sure whether it's been successful or not. I'd say a little bit, but there's still a lot of rust here. So I'm just going to resaturate it and let it go for another 24 hours and to see what happens. And I'll do the same. I'm also doing this on my magnetic chuck, and it's not an electromagnetic chuck, it's just a regular magnetic chuck. But hopefully I'm not throwing good Evaporust after bad. This pig mat stuff is awesome. It's yeah, if you haven't ever used it, all of the cleaning that I did on this machine so far was with pig mat paper towels. And in fact, they don't act like paper towels. They act more like a rag. They don't fall apart. It's incredible. They just stay together. One other thing I'll mention is that I had to draw this from my 5-gallon bucket of Evaporust. I also have a 1-gallon container, and I'm going to show you in just a minute, but I opened it and it had congealed. Now, I've never experienced that before. Granted, I've only been using Evaporust for about a year, but it was pretty interesting, unexpected. I took a picture of it, and I'm going to send the picture to the company and just see what they can tell me about it. Should I be worried? Is that just what happens when it gets fully saturated with iron or rust, iron oxide, so that it can't absorb anymore? And if you give me a second here, I'm going to find you guys a picture of it or a video of it. So really quick, I'm just going to show you a picture or a little image of the Evaporust pouring out into this container so you can see what I'm talking about. It's just glop. And I didn't know this when I first started doing this yesterday working on the table, because there was some liquid up on the top, and I decanted that, and it was enough to fill up this container 2 times. And then I came out this morning to work on it, and was just met by this huge pile of glop. So if you don't mind, leave me a comment and just let me know if you've ever experienced this before. Like I said, I'm going to send some pictures to Evaporust and see what they can tell me. In addition to working on the table on the surface grinder yesterday, I also spent some time staring at this electrical cabinet on the side in order to try to figure out what's going on, and I did figure it out. So what we essentially have are 2 separate motor starters. This is a motor starter right here, and the right side over here is a separate motor starter. Now, what is a motor starter? The web says that it's a device used to safely start and stop an electrical motor. Yeah, what does that mean? Well, I'll tell you that there are 3 safety functions that this motor starter provides. First, it has a mechanical on-off or open and close connection, which is moved by this handle on the door that we looked at yesterday. So first, you have to physically close the circuit and allow power to flow through it, and then it's fed to this contact block here. From this contact block right here, power is fed over to this motor starter and also stays with this one here. And it's fed down to first a latching relay or a latching coil, and secondly over to a pair of heaters. So what is a latching coil or latching relay, and why is it important? This relay, essentially, when power goes to one side of the coil and then is grounded, it magnetizes the coil and pulls this up. And when you pull this up, the electrical connection is made between the power supply and the wires leading down to the motor. And once turned on, it will stay on till one of two things happen. You hit the stop button and disconnect the electricity, or power goes out in your shop. Now, why is that important? Imagine you're in a situation, you're in your shop working on a part, power goes out, you're standing there for 5 seconds not knowing what's going on, and all of a sudden the power comes back on. Now, if you didn't have this latching relay and the motor, the on switch stayed on, the motor would kick back up, and there's a potential to damage your part or hurt yourself. But since power was disconnected, it essentially turns off the power supply to the switch, and it can only be started again by hitting the on button. So that's the safety function of this one. And then the third safety feature of a motor starter is these heaters, which are essentially fuses. So power, after the relay connects the circuit between the power supply and these wires to the motor, these heaters act as fuses. So every motor has designated horsepower and designated amperage. So these heaters are sized specifically to the amperage draw for the motor that you're using. So if you came in, this is a 1.5 horsepower motor. I forget what the amperage draw is right now, but if you tried to hook up a motor that was larger than the amperage supply of this motor, it would burn out these heaters, and it just wouldn't work. So you'd have to make sure that these are sized appropriately to the motor. So again, once it comes through here, then it winds its way down and heads over to the motor, and it runs. Now, what's up with this second motor starter? That for a second I didn't understand what was going on, but now it all makes sense. So remember, yesterday we found this other switch on the exterior that was a start and stop, and then I was also cleaning around this thing, not quite recognizing what it was, but this is a 4-prong electrical outlet over here. And so, 3 wires of the 3 phases, and the 4th is a ground. So you could essentially plug another machine into this and power it off of the same incoming power source that is used to power this machine. Now, why would you have that? I thought about it a little bit. Perhaps you have a vacuum system, or you have a vacuum motor or vacuum machine that's on wheels that you wheel around your shop, and you can take it over to the various machines that you're working on and hook it up so that it sucks up the debris that's coming off of the cuttings or the grindings. So if that were the case, you could wheel it over here, plug it in to this machine here, and then use this switch to turn it on and off. Now, what's interesting is that, again, this thing has heaters, and the motor, these heaters have to be sized to the motor. So realistically, you could probably only hook this up to one machine in the entire shop. And that's why I thought, well, maybe it's the vacuum cleaner. Maybe they have plugs like that on a lot of different machines in the shop, and they just wheel around and use the vacuum. Uh, One other thing to note, yesterday I pointed out that this was a 220 volt machine motor starter. This was a 440 volt. That's what the nameplate says. But in reality, this one has been converted over to 440 volt, and you can tell because the coil, which is part of the relay system, the latching relay, is now a 440 volt coil. Originally, it would have been a 220 volt coil. This one also has a 440 volt coil, so again, this is for a 440 volt power. And I was able to get my camera into the motor compartment of this machine and contort and take a picture. And yeah, this is a 440 volt motor. I knew it would be, but it's just nice to be able to visually confirm that. Just for giggles, I've turned on my three-phase power supply and just want to demonstrate really quickly that how this functions. So recall out here we have this on-off button which will power this side. So watch this contactor here when I hit the on switch. Oh, whoops. I forgot to hit the mechanical on switch. Okay, now it's on. And see, now the relay is latched, and it stays latched until I hit off. On, off. And in the same way, watch this relay over here, and this latching relay. On, off. On, off. Now I'm going to do one other thing. I'm going to turn this on. I'm going to walk over to the wall and unplug it. And what happened was that this turned off again, and it won't be reconnected until you hit the start button on the switch on the door.
Since we're talking about motor starters and latching relays, uh, let's take a look at some wiring diagrams so we can understand how these things work. Now, a three-phase latching relay with momentary start and stop buttons is a fairly sophisticated concept. So let's start with something much simpler and work our way up to the three-phase setup. So here we have just a very simple setup. We have power coming in through L1 and ground going out through L2. We have an on-off switch here, and when the switch is closed, the motor turns on. And when the switch is opened up again, the motor turns off. Now, of course, that doesn't get the benefit of the latching relay, which is when the power goes off and then turns back on. Now, this motor is going to turn on again if you left the switch on. Let's now add a relay circuit and also a contactor to the situation and see how that impacts the turning on and off of the single phase motor. So the way a relay works, which is like a contactor, is that when power flows through this coil here, it magnetizes and it causes these two contactor plates to move together. And when it does that, power can then flow across the contactor plates from the L1 to T1, and then on the neutral side, it flows back out through T2 back to L2. So when this switch here is closed, the coil energizes, the contactors close, and the motor turns on. And when this switch is open, the coil de-energizes, the contactor opens up, and the motor shuts off. Now, just like the prior example, this isn't really helpful in the case of a motor starter because if power were to turn off and then back on, the motor would turn off and then back on. So you don't have that safety measure of a latching relay. However, a situation like this is really good for something like lights on a vehicle. For example, let's say your truck has a big light bar putting out 500 watts of power. You do not want 500 watts of power running through the switch on your dash. It's probably going to melt the entire switch and the whole dash too. So instead, what you would do is you would use a relay. This switch here would be the headlight switch, and light power would go through here when you turned on the lights or turned on the light switch, run through the coil and go back to the negative, and this would close the contactor, uh, pulling these lines together. And this power over here would probably run straight from the battery. So that's a situation where a relay circuit like this might make sense. In this third drawing now, we've added the latching relay. So now we're getting a little more complicated. And again, we have power in and out. We have contactor here with a coil, but now the power is fed to the latching relay from the hot lead on the motor, and the ground is going to be the ground lead on the motor. So power comes in here, goes through the coil, and it gets up to this point, but then it has nowhere to go. We have two buttons here. We have a start button that's normally open. That means that it's disconnected. And we have a stop button, which is normally closed, which means it's normally connected. And these buttons are momentary, meaning the start button, for example, only works when you're holding down the button, but it will go, and that will take it to normally closed. But when you let go of the button, it will go back to normally open. So power comes up to here. It can't go this way to ground because this is open, and it can't go this way to ground because the line runs through the contactor, and so energy can't hop across here over to the ground. So then you press the start button. Now, when you press the start button, it closes this circuit here. Power now can make its way through the coil up to here and back to ground. So what you would do is you would hold the start button until you hear the clunk sound of the contactor closing. And once that happens, you can let go of the start button. And then it will look something more like this. Power coming in through the relay coil, exiting, going through the stop button, which is normally closed, coming around the horn, and now these contactors are closed. So this can ground to the negative through the contactor. And likewise, the motor is now running because power can make it through the contactor and leave again through the ground or the neutral in the contactor. Uh, and this will continue to run until you either disrupt the power source here or you use the stop button. So let's use the stop button. So now we've pushed on the stop button. The normally closed switch is now open. And once again, the power has no way to make it over to ground. And so that de-energizes the coil. This gap opens up again, and we no longer have power going to the single phase motor anymore. We're almost there now. Uh, let's add in a third phase here. So now we're going to have a three-phase system connected to a three-phase motor. And then we're also going to add in two more parts that make up the motor starter. And we end up with this title here, a three-phase motor starter with latching relay and momentary start and stop button circuit. I'll start by saying the latching relay is essentially identical to what we saw in the single phase circuits. So we don't have to worry too much here about that. The only difference is instead of power coming from the hot lead and leaving through neutral, power now comes in through L1 and could leave either by L3 or L2. And in this diagram, I've chosen L3. Other than that, the latching relay is the same. We've also added in a couple components to make up the motor starter. Usually a motor starter will have a fuse, some big fuses up here to protect the system past the fuses down all the way down to here. And it may also have a big on-off switch. And there is actually one in the motor starter in my surface grinder. And the other part that this has is an overload relay or an overload heater. The overload heaters, in spite of what I said earlier, are not quite fuses. They're like fuses, but they allow the motor to gradually heat up over time and pull a little bit more power or less power, depending on the situation, without disconnecting the circuit. Now, fuses sometimes are more absolute. You know, if it's a 10 amp fuse, you go to 11 amps and the circuit blows in a fast acting fuse. Well, these heaters or overload heaters have a little more ability or wiggle room. So beyond that, there's not too much else to discuss here. I have put together a series of drawings which can be found through a link in the description below. And I've done the same thing that I did with the single phase, which is, we start with um, no power going through the latching relay. We press the start button, which initially energizes the coil by closing this circuit. And then we hold down the start button until the contactor moves. And then we have this second circuit for ground now that goes through the contactor and back up to L3. And so this now continues to run until we either disrupt power coming from L1 or we open up the stop button here. And I just want to make note, these are all shown as a switch here. When the motor is running, obviously these would all be closed, but I just left them as they were here, just to signify that it's a switch that can open and close. But in this case, these would be closed for the motor to be running.
Well, this is going to wrap things up. As always, I'm grateful for your company. Thanks for coming to check out the video. And we'll see you in the next video, which will most likely be about this surface grinder again. All right. So long for now.